Hello, everyone. Good morning. I'm James Katwere. I'm going to take you through the land productivity analysis tool. Hope everyone can hear me and hope everyone can see my shared screen. I'm going to take you through the land productivity analysis tool. First of all, I'm going to go through it theoretically. I'm going to go through it theoretically. That means following these slides. And after, what we will call the practical session, it was of my knowledge that members will follow me as I do in the practical session. And that again will also be it will be a self-evaluating practical session. If we get the same results as I've gotten in executing the tool, then it will be a pat on the back for yourself. So first is the theoretical part where I'm going to go through the slides what each and everything means, and later we'll go through the practical bit in the real GIS environment, which is QGIS. Starting from the background, I understand the former facilitators in the preceding sessions have taken you through this, but we developed a land productivity analysis tool that covered the scope of 10 countries. That's Djibouti, Eritrea, Ethiopia, Kenya, Mauritius, Rwanda, Somalia, South Sudan, and Uganda, using observation data sets. And I think it's the facilitator yesterday in this session, we will use data sets that were provided as part of the facilitation material for this session. There are two data sets that are required to execute this tool. One of them is the soil. It's a soil layer for the whole region of the 10 countries. The second is the survey layer, or soil adjusted vegetation index layer. And like I said, the facilitator yesterday must have taken you through QGIS. QGIS gives us the ability to develop on top of it, or to extend its ability through what we call plugins, where a project like this, despite depending on what is pre-existing in the QGIS software, we can, on top of it, develop custom software or tools like the land productivity analysis tool on top of it, through what we call its extension framework. This tool processes data sets as inputs and generates land productivity indices, two indices, the soil productivity index and the net primary productivity index. All right, this is part one. We are presenting the land productivity analysis QGIS plugin. Like I mentioned earlier, QGIS gives us the ability to extend its functionality on top of what is existing inside. And it's through what we call plugins. We can develop and automate geoprocessing workflows that, for example, compute land productivity analysis is the scope for this for the project. So it's what we did. We developed a plugin for land productivity analysis that inputs data sets and outputs land productivity in terms of two indices, that's soil productivity index and the net primary productivity index. In this session, as you'll see later, we use provided material as the input data sets we will use. I'm sure those were shared with you. And in this session, I'm going to tell you to take you through the step-by-step process of sourcing the plugin, installing it, activating it, executing it, and outputting its output, which is the learn productivity indices. So, as a refresher, the tool is meant to geoprocess input data sets to generate the two learn productivity indices, that is the solo productivity index and the net primary productivity index. You learn how to install it, execute it, and output the results. As you might have earlier, I'm sure all participants, you were taken through the process of installing QGIS. This particular plugin uses QGIS version 3 and above. It was versioned to support what we call long-term release. That means all through the versions of QGIS 3 that are later to be released, it will still support them. A minimum working compute of 2 GB of RAM and 5 GB of disk storage and an internet connection. Remember, we're supposed to download this plugin from the plugin repository that is hosted by qgis.org. Okay. On a freshly opened QGIS, hope it's okay you follow this as I'm doing. This is so far the theoretical part. QGIS will look something similar to this if you've just opened it. You trace a toolbar menu item called plugins. And when you highlight it, it will drop a menu called manage and install plugins. When you click that, it will take you to a form from where you can type in the search bar learn productivity analysis tool. By the time of this recording or taking this screenshot, it is the only plugin that returns after your search. Maybe who knows later, but it's the full name of Learn Productivity Analysis Tool. You can even read its description, the publisher, which is of course RCMRD. If in any case there's any other tool that resembles it, at least you install that from RCMRD, the publisher, by clicking on the install button, or it's labeled install plugin. A question for those who may be using French or any other language, but the plugin is published in English. It's only the interface change in language that will, I think, change, but the wording, the metadata, the publisher, what it does will still be in English. So you've searched, you've located it, you've installed, you've clicked the install button. It's not always automatic, but after installing, some versions which came later, they activate or the check mark next to the installed plugin will be checked. Others in previous versions, it may not. So you have to in those instances, you have to check it to activate it manually. As you can see here, after activating it, you can close that window. So the next objective is, how do you launch the tool? We are taking the assumption that you installed it, activated it, and it showed no errors. So how do you launch the plugin? Like before, in the menu bar, you locate a menu item called processing, and below it, it will show a submenu. On top, it will be the toolbox submenu. When you click on it, it will open a panel, most probably on the right of the QGIS main interface. And amongst the many tools and plugins, some of which are inbuilt into QGIS, you will see a publisher called RCMRD. Click on the expansion icon that will reveal the just installed Plan Productivity Analysis tool. And when you click on it, it will do what? It will launch the tool. Those using an assumption maybe we made is all of you are using Windows, but some of you may be using a Mac or a Linux computer. Some of you, your computers may even be touch-based using a stylus. So when I say click, tap, or double click, depending on the operating system you're using, it will launch the tool. And the tool that is launched will look like this. So the launched tool will display an interface like this. That interface isn't static. Depending on your screen resolution, you may either need to resize the window to see everything. Some of you have very high definition or high resolution screens where maybe it will be kind of clamped, but the window will have resizing handles if you click on it, and you'll see interface like this. The interface on the right side, it reminds the user of the purpose of the tool, the input data sets, that is the soil productivity index layer and net productivity index layer. By that, I mean the soil layer that was provided to you in the facilitation material, and the survey layer, which was also provided. Below that description, it is a glimpse on how you will interpret the computed results. It's a table which on the left shows the classification and what that classification means, from extremely low to very high. Then on the left of the tool, these are the parameters or the input data sets with input fields where you click the select button that is nearest to the input field and locate the data set that you will input in that field. It is labeled soil productivity indice and net primary productivity indice. And then it prompts you the name or where you want to store the output. Below it is the progress bar, which will start from 0 and go up to 100 as your computed results are being geoprocessed when you click the run button. But of course, after everything goes as planned, you can close the tools window, either using the X in the top right corner or the close button in the bottom right corner. This is so far what I've explained. Launching the tool successfully will present an interface that prompts you for the input parameters and the short help summary of what you're really computing. Yeah, this input summary, given that QGIS, you can even see the results before you even close the plugin window. You can still refer to the plugin window, which is still open, to really interpret the results. Yeah, you will not necessarily have to close it, but if you on a small screen, it may take up your screen real estate, but it will be in the background. This is so far what I've explained. The highlighted portion named 1 are the input data sets. They're the soil productivity indices, the net primary indices, and the output data sets. The highlighted section 2 is the description, what those inputs are. Highlighted section 3 is the classification guide that you'll use to interpret the computed or outputted results of the tool. 4 is the progress bar that will interactively show you progress as the inputs are being computed. 5 is the run button. Of course, you have to click it first before the progress bar runs. 6 is a close window, same as closing, you're clicking on the X in the top right. And 7 is what we call batch processes. That is inputting either each country, if you have the data sets for each country, inputting them in a chained manner or in batches. It even helps them to be computed in the background while you're doing something else. It does the same thing, but in batches. So these are the sections as they were highlighted in the previous screen. And for batch processes, if for those who need extra interpretation, like I've said, you can run very many data sets at once. Some data sets you may say that, okay, I'm running all the 10 countries that were not in a single input data set, but each of them was in its separate data set. So you can run them, all of them, in a batch process, whereby each and every row is a country of its own. That sometimes makes sense if your computer is not very strong, that you prefer running them in batches, that if you input the whole data set at once, it may really consume a lot of your computer resources. So this is where the batch process comes in. This is so far what I've explained, where each row can represent a country, a specific data set. And the outputs are the same as those that were run as a single data set, a combined regional data set. Executing the tool, you can see logs. While executing the tool, as it's progressing, as you can see in the progress bar, the logs we see are basically as a feedback, as processing is going on. Maybe your computer is out of disk space. Such logs will be displayed here. If the tool may halt or stop, not knowing why it stopped, but all the logs are what? Are stopped here. And these logs, displayed logs, are also a way we get feedback from you users in using the tool. You copy these logs, put them in an email, and give us feedback in order for us to know what really happened, either as a way to improve the tool, as a way to troubleshoot and give you help on why you stuck. We can only give you help, feedback, and even improve the tool through these logs. And if everything's successful, the logs will also display message successful. Like the message that is indicated here that the algorithm finished successfully. And after that, this is what you will see in your layer window and what will be rendered in the map window. On the left, it will be a legend for each. Remember, we said land productivity is computed and outputted as a combination of two indices. The soil productivity index, in this case, we named SPI, and the net primary productivity index, in this case, we named NPP. These are arbitrary names, but for purposes of practicality, you give it the name you want. During that part of the tool prompting you for where do you want to store the output layers. So in that file manager window, where it prompts us where do you want to store the output and with which name. For the soil productivity index, we named it SPI, and the net primary productivity index, we named it NPP. Yours may be in full form, not acronyms. And as a guide for these produced or outputted layers, they're outputted or classified from very low productivity, moderately low productivity, high productivity. That's for the soil productivity index. And for the net primary productivity index, it's extremely low productivity, very low productivity, low productivity, slightly moderate productivity, slightly high productivity, and very high productivity. Of course, you can turn this layer on and off to see the layer below. but the interpretation of these productivity classifications are the ones which were presented in the help section of the tool, which each and every classification means as far as productivity is concerned. So if you had not closed the plugin, you can still refer to it to gain more insight. This is what you see if you turn off the SPI layer, like you see here. It's not turned off, it's turned off, so you can see the layer beneath that was overlaid below the SPI layer. And this is a legend that was previously shown on the left side of the layer. And this is the table that the tool was displaying for interpretation in the help section. They're all there for you to further interpret what you see. Where extremely low means those portions of land that are entirely bare or rocky, up to high, very high, which showcases portions of land with very high standing biomass, close vegetation, for example, grasslands, shrubs, and forest or cropland. So this further helps to make interpretation of the results you've gotten. Remember, it's also, this table is also in the help section of the tool. So to find yourself, even if you've already computed, you can still execute the tool. Just launch it, not execute, to further read this interpretation of the classification shown in the legend. So before I go to the practical bit of the session, the land productivity analysis tool also got an upgrade of its web version. The web version of the tool was based purposely for users who may not have or may not be at liberty to install QGIS locally on a machine. If you're in a conference somewhere, if you're in a workshop somewhere, you want to showcase the tool, you can use the web to still access the tool. If you're a student, if your computing resources at the moment can't allow you to execute the tool, either for permission purposes, in any way you can't access QGIS, you can still execute the tool. The good thing with this, all you need is an internet browser, either on mobile or even on a computer. So it was a way to make the tool still available to users on the go, on the move, anywhere, everywhere. Yes, we made it using web technologies, but the good thing is QGIS as a GIS execution environment also offers QGIS server, where all computing capabilities QGIS has on the desktop environment, it carries it over to the web or its version of QGIS server. That conforms to the Open Geospatial Consortium standards of web mapping services, web feature services, web coverage services, and the tool was architectured in the way to conform to those standards using the architecture you see in this drawing. Not as an improvement to what is existing, but to adopt it to the unique capabilities of the execution environment. The web environment, in a web environment, for example, a user on the go may want to query features, may want to rearrange layer tree, do a search, do annotations on the map itself, measure distances, areas, perimeters, and so forth. Do annotations like sketching on top of what is viewed, like redlining, annotations, and so forth. Generate permanent links, print a PDF, the real map layout, take screenshots, but also export the output in other formats, vector or raster, to share with others on the go. That means even if you are in a meeting somewhere, you can access the tool as long as you know the web URL and share or extract a portion of the output of the land productivity analysis tool for your particular country and embed it in a report. But it doesn't mean that exporting the tool to the web, you lose the interactivity. The same interactivity you had in the desktop environment of playing or interacting with a map, zooming, panning around, rotating. The web tool also gives you those interactivity. The same way you had on the desktop version of the tool. On launching the online version, this is what you see. It is made as what we call a single page application where the map is the center of attention. Menus, menu items, links are all made to disappear, and the map is the center of everything. Menu items for panning around, zooming, changing the base map. Are made in a way that they don't interfere with the visibility, as you would normally know from other websites where you have to navigate, remember the navigation, the site navigation map. No, you launch it, the map is there, it's computed in real time from the same data sets you have. The good thing with the online version, the data sets can be updated in the background as changes happen. You can still access the legend for each of the layers. You can even turn them on and off. For example, if you turn off the very low productivity section of the output, which are low productivity, the map returns, the rendered map is without those particular portions. You can share. If you click on map tools, you can share this very map with a colleague, with a research colleague. The same way we share content on social media, the same share philosophy is borrowed and carried over to the tool. You can print to PDF using a resolution of your choosing in the orientation of your choosing still. You can access other map tools to measure distance, like how long a patch of low productivity stretches from this border of the country to another border of the country. Use cases like that. You can do redlining, like annotation. You will annotate on a screen, but this time around you're using your mouse. For those with a touch screen, you can use your touch to highlight or bring attention to certain areas of your particular analysis. You can export in standard image formats by just dragging a circle of your area, just dragging a rectangle as your area of interest and export to any format to embed in a document, in a report, in a presentation, and so forth. So far, this is the end of the theoretical bit of the presentation. Now I'm going to go to the practical bit. If at all there's anything from the moderator, you can go ahead.
James, you can go ahead to the practical bit. We'll take the question.
Okay. Now I'm going to locate my QGIS. Click to launch it. For those of you who this is QGIS. Mine looks like this. Yours may not. Mine is in dark mode. Yours may not, but it's basically the same. It's basically the same. So the first portion of the last presentation, the theoretical part of the presentation, was how to locate QGIS. QGIS as a plugin, or QGIS as an organization. They have what they call a repository, where tools like this from publishers like RCMRD do submit their repository. These repositories go through scrutiny and they are approved to reside on the repository. How do you locate this repository? Like in the previous presentation, You locate the plugin menu item. Under it, there's a sub menu item called Manage and Install Plugins. The install plugin window comes. It prompts you with a search bar, this thing. Inside it, you type land productivity. Remember, in this whole thing, you must have internet. So when you're searching it, it returns land productivity. And when you click on land productivity, it shows what the tool does, who the authors are, and the several tag information, what it does, or categorical tags to categorize the plugin. Remember, there are very many. So plugins that do, let's say, surveying may have that. But this, since it does with land, it has these tags. But what should be most important, it's one which is published by RCM-MRD as the custodial author. Then click install plugin. It will take a few seconds. It will even give you a prompt, successful response that it has successfully been installed. Now it will have a tick that is installed and activated. You can further check it from those which are installed. In case you want to uninstall it, you highlight it and say uninstall or reinstall. Now I'm going to close this window and go on to the second objective of the last session of how to locate the land productivity analysis tool. Still like the plugin menu, this menu toolbar, we locate processing as the menu toolbar menu item. Under it, there's toolbox. In toolbox, we click on toolbox. Toolbox will open a panel, a toolbox panel. You can either search it from here, land productivity, and it will come, or else you can look through the list of providers and locate RCM-RD and double click on land productivity. Like I said in the previous session, it's a sizable window. You can resize it. For example, if you want to see all the content. But one thing I do after locating it, I close the tool panel, the toolbar panel, so that I gain more screen real estate to see more things on the screen. Like I said, mine is in dark mode for my eyes. Yours will obviously be in light mode, but there's no difference. This is the toolbox window. Like we saw in the previous section, this left side gives quick help on the tool itself, what it's used for, the data sets it's going to use. So for example, to compute soil productivity indice, this section of the help says to compute soil productivity indice, it will need a what? A soil data set. This is provided by FAO, or the Food and Agriculture Organization. The second section says in order to compute net productivity indice, you will need input. The survey input or the soil adjusted vegetation index, and in the top bottom part of the help section is the interpretation of the classification of the legend of the output we'll receive. On the left side, we have the soil productivity index, how you locate the data set to use in computing it. Next is the net primary productivity and the input field where you input the data set, that is the survey layer or the soil adjusted vegetation index layer, which is a raster, and how you locate it on your computer. The output layer where you want it to be stored on your computer and give it a name. And the net productivity index, net primary productivity index output layer where you want to store it on your computer and give it a name. So this is the progress bar. This is the run button to start executing the tool. This is the close button. And this is the batch processing side of things. It's in this where you, for example, if you have a data set that are broken down for each of the country, I don't know if those were given to you. This is where you put them instead of computing all of them as a single process like you see here. But this time around, you're computing them in batches. The use case I mentioned for that was those with either slow computers that can't input all the data set at once, the big regional data set at once, that you want to compute them in batches, one after another, instead of one big chunk of regional data sets. So right now I'm going to input the data set and execute the tool. For the soil productivity index, I'm going to use the data sets, which I believe we are also provided to you as part of the training material. I'm going to click this button. I have a folder called regional. Inside it, I have the regional soil data set. I'll click on the shapefile, one specifically with a .shp file extension. I will locate a data set for computing net primary productivity indices, that's the survey layer. It's also on my computer within the regional datasets folder. It is a raster file. Here, I will launch the file manager prompt on where to store the output for the soil productivity output. So I'll save it to a file. You can save it to a GeoDatabase, to a database table, or just leave it empty to be output as a temporary layer but for organizational purposes, we're going to save it as a file. We're going to save it as a file. Save it as a file. Can create a folder, say results. Inside results, I'm going to call it SPI4, a short for soil productivity in the sea. Sorry, I'm going to repeat this again. I'm going to call it, store it as a shapefile. I'm going to call it SPI. I'm going to do the same for the net primary productivity in the sea. Net primary productivity, and it will be saved as a raster. And I'm going to click on run to execute the tool. You can see the outputs here. Or logs until the algorithm says it's successful. You can either just click to the tool or set this at the side in order to further interpret this. You can set it aside, there's no problem. And this is the output. You can zoom in. You can toggle layers on and off to see the underlying layer. So this is the output. Like the project says, land productivity is computed as a combination of two indices. That's the soil productivity index and the net primary productivity index. The net primary productivity index is classified in 4 classes. That is the very low productivity. Those are the areas in red. You can even switch them off and see them disappear. The second classification is low productivity, which is the shade of a very pale, I can say orange. You can switch them and see them on and off and see. Next is moderately low productivity. You can switch them and see. Then if there is high productivity, this is, you can not really see the changes, but it's there. Then to see what's underlying below the soil productivity index, I can toggle the soil productivity index layer and I see the net primary productivity index. It is classified with 8 classes ranging from extremely low productivity. Those are the areas in red. They are mostly in water bodies. Very low productivity. The slight pale color of a version of red. Low productivity, slightly moderate productivity, slightly high productivity, and lastly, very high productivity. Why I didn't close the tool was this, on how to really interpret these in case you need more insight. Very low productivity, this is what it means. Portions of land that are extremely bare or rocky, up to what? Very high productivity using this key as a guide. That's why I didn't close it. You can either close it or not. So this is the output of the what? Of the tool. From what you learned on how to use QGIS in the previous sessions, you can also save this project as a .qgis file. You can save it as a .qgis file, either as a zipped QGIS, one which is compressed, or the normal QGIS. Name it land analysis, or for better context, you can say regional. It will be saved as a QGIS file in a location of your choosing, where next time you don't have to execute the tool, you will just use the results you have already saved in a QGIS project file. Now, this is the plugin desktop. We can go to the web-based version of the what? Of the tool. So I want to resize the browser window so that you can see what I'm typing in. So the URL, like we said, is a web-based tool, all web-based using internet technologies, and any resource on the internet is gotten via what we call a URL, or the universal resource locator. So the URL for the tool is landproductivityanalysis.com. When you launch it, this is what you see. The results are computed on the fly, and you see the same map as you saw on the desktop version. You can see the legend is still the same. You can pan, zoom, rotate, and so forth. In the web-based tool, the map is rendered like this. The map items for going home, that is rendering it to the center at the default zoom, home. You can position it, or you can use manual controls to zoom in and out. You can change the base map to no background, or to a base map to have spatial context of where each country is. To see the map legend, like we saw in the desktop version, this is the map legend. You just hover over the legend thumbnail for soil productivity, you'll see it. and the net productivity. Legend is also, it computes what's really there, and for this purpose, it computes mostly the ranges of what? High productivity to very high productivity, but you can also use this legend here in case the other one pops away. What we can see from here, we can also turn off layer one on top of the other to see what's below it. But the web version also gives you the option of what? Doing some spatial comparison analysis to see what falls where. So you can play along with this slider to see which area overlaid on top of net primary productivity is, say, for example, very low for soil productivity index. That is seeing the legend. We can see more tools. For example, to share with a colleague, generate a link to share with a colleague. It even has a QR code. You can share on Facebook, Twitter, LinkedIn, and WhatsApp. You can bookmark it a certain location so that, remember, we are using the OGC or the Open GEOS Consortium standards or protocols. One of them is called WebMap WMFS or OTMS, Web Mapping Tile Services, where you can bookmark certain tiles to be cached in your browser so that the next time you visit the tool, you don't have to reload those tiles again. But the most important tools are within the map tools, where you can identify a region. You can do measuring. By measuring, I mean you can do length, for example, measuring from here to here. You get it? And you see the distance. You can do area, where instead of just length, you can measure area. Okay, the use case for something like this would be, say, like, okay, in South Sudan, for example, how much is this area, which is covered by this portion? Back to map tools. That's one of the map tools. You can measure, you can do redlining to do annotations, you can see the attribute table. But most importantly, people who embed this in reports mostly prefer exporting an image either in raster format, JPEG, at whatever resolution they so prefer. They just highlight, for example, choose an area of their interest, and then crop away that part. Sorry, my browser was blocking that. Let's see, JPEG, PNG. PNG. Okay, let's say this resolution. Refresh it again. And this kind of image is exported for you. You can save it and later embed it in a map, in a presentation, in a report. Like I said, this online version of the tool is to extend the original desktop version for mostly users on the go who may want to input or output something in a report, in a presentation, in a workshop, something like that. We can also print in a region of interest and print to what? To PDF. And then save that portion of the map in PDF. So you can seek for help, but also the very tools that are in here are also provided in here. And that's basically it. It's basically to extend the desktop version of the tool to the web environment for users on the go who may have some bit of resource constraint for some reason or another. They have not been able to install QGIS for some reason or another, but they can still access the tool.